Find the lateral surface area and volume of the frustum rounded to 3 significant digits. Alright, so the lateral surface area of a frustum, just pulling this from a formula sheet, the lateral surface area of the frustum of a pyramid is 1/2 parentheses P1 plus P2 times S. So you definitely need to know how to use these formulas. That's why I'm doing so many examples like this. It looks like this is a square-based, there's a square base on the bottom and on the top, so let me kind of examine these each individually. Everything is in yards. Okay, so this looks like 3 yards square. It's a square. So the perimeter of the top part is 12 yards, and I'll call this P1. And the area of this top part, since this is 3 yards by 3 yards, would be 9 yards. 9 square yards, I guess. This bottom square, it looks like this measures 7 yards by 7 yards. So the perimeter here, I'll call this P2, would be 28. That's 7 plus 7 plus 7 plus 7, or 7 times 4. That's how I did it. 28 yards. And the area of this bottom base, this one right here, would end up being, let's see, 7 times 7 is 49 square yards. Okay, so kind of figuring that stuff out so that I can just plug the numbers in as I need them over here. So the lateral surface area, again, is going to be the sum of the two perimeters. So perimeter 1 is 12 yards, perimeter 2 is 28 yards. 12 plus 28. The slant height is 4.5 yards, it looks like. It actually gives us that number twice, 4.5. So let's plug this into the calculator. 0.5 times parentheses 12 plus 28, close my parentheses, times 4.5. We get 90. This would be 90 square yards. This actually says rounded to 3 significant digits, so I'm going to go ahead and call this 90.0 square yards so that it has 3 significant digits. We're also trying to find the volume of this frustum. We're not caring about the total surface area of this frustum, apparently. We are caring about the volume. So again, looking at my formula sheet, I get volume is equal to 1/3 times h times parentheses a1 plus a2 plus the square root of a1 times a2. Close that up. This gives us 1/3 times the height. Actually, let me not do that in parentheses. Times the height. The height of this guy is 4 yards, so times 4. The area 1 is 9 yards. Just writing down these numbers as I read them. This one's 49 yards. And then we have the square root of 9 times 49, which will give us 1/3 times 4 times parentheses 9 plus 49 plus the square root of parentheses 9 times 49. Close the two sets of parentheses. We get 105.3 repeating. We're rounding this to 3 significant digits, so I'll call this 105 cubic feet. Or cubic yards, not cubic feet. Find the total surface area and the volume of this frustum rounded to 3 significant digits. It looks like this has hexagonal bases. So I'm going to need my formulas for hexagons in addition to my formulas for a frustum. We're trying to find the lateral surface area and the volume, just like the last problem. Pulling the formula for the lateral surface area from my formula sheet, we get 1/2 P1 plus P2 times S. So I'm going to need my perimeters. And for my volumes, I already know I'm going to need my areas, so I'm just going to go ahead and figure all this stuff out right now. So for the smaller base, that's the one down here. It doesn't really matter which order we do these in. I don't know why I'm doing the smaller ones first each time, but I am, so deal with it. This is 3 centimeters for each of these 6 sides here. The perimeter, since there are 6 sides, would be 18 centimeters. 3 times 6 is 18. There's 6 sides. and I'm going to call that perimeter 1. The area of this this is going to be 2.598 times 3 squared. This is just a formula, the formula for the area of a hexagon. I'm using the 2.598 as my rounded version. This is 4 significant digits. We're going to be rounding this thing to 3 significant digits, so I don't think this using to 4 significant digits would be a problem. That's why I'm comfortable doing it. If we need more significant digits, we could always go with the more exact version there, but we only need 3. 2.598 times 9 is 23.382. 23.382, okay. That's not area 2, that's area 1. And then for the other hexagon, this one has 6.5 centimeters for each of the sides, so the perimeter of this one, P2, 6.5 times 6 is 39 centimeters. And the area of this one, again, 2.598 times 6.5 squared, 2.598 times 6.5 squared is 109.7655. Okay. So those are the perimeters and the areas that I'm going to need. So for here, 1/2 times the sum of my two parameters, that's 18 plus 36. Times the slant height, which is 7.6. Times 18 plus 36, close the parentheses, times 7.6, which gives me 205.2. We're told to round to 3 significant digits, so that means I'm going to round this off to 205 square centimeters. For my volume, pulling this from my formula sheet, I get 1/3 height A1 plus A2 plus the square root of A1 times A2. So 1/3 times my height was 7. A1 is 23.382. A2 is 109.7655. And then I have the square root of 23.382 times 109.7655. That's all underneath the square root. And again, I want to point out I'm not rounding these numbers in the middle of the problem. I want to wait until the very end of the problem to do any sort of rounding to minimize any sorts of errors that I'm creating when I round. So 1 divided by 3 times 7 times parentheses 23.382. And, you know, what does it matter? The calculator is doing all the hard work here anyway. Times the square root of 23.382 times 109.7655. We get a rather large number. Yeah, that seems reasonable to me. 13,029. 13029.827. We're rounding this to 3 significant digits, which would be 130 or 13,000, I guess, cubic centimeters. Now, since this since the third digit that I'm rounding to was a 0, I want that to be written as a significant digit. You can see I'm doing the overbar over my 0 there. It's 13,000, but there's a bar over the first 0 there to show that that's where my significant digits go to. Let's see. The reason I think that does seem a bit high, doesn't it? Ah, I see what I did wrong. I'm looking at my calculator here, and I accidentally said times instead of plus right here. So yeah. What made me notice that this was kind of out of the ordinary is a bit large. Is if this was This would, I mean, I would be on par with having a 10 by 10 by 10 for an area. This is approximately 10 centimeters across. It's a little less than 10 centimeters tall, and less than 10 centimeters that way. So in total, a 10 by 10 by 10 cube should have around the same area that this guy does. And you can see a 10 by 10 by 10 is 1,000. And so if I was to, that's kind of what tipped me to the fact that that should be too big, or that 130 or 13,000 is too big. Don't let the fact that these volumes do tend to be much larger numbers than everything else, that alone shouldn't necessarily dissuade you or make you think that something is wrong, because volumes do tend to be much larger. If you're talking about a home that measures, let's say, 30 feet by 50 feet by, let's say, I don't know, 15 feet tall, then it does have 22,000 square feet, or cubic feet rather, of space. But you can see I was comparing a 10 by 10 by 10 total volume to the volume I got on this guy. In any case, when I change that to addition, I get 428.88, whatever. So let me cross this out. 428.8865. If I round this to 3 significant digits, that's this place right here, so we get 429. I'm rounding up because the next digit is an 8, and this would be in cubic centimeters. Okay, that seems more reasonable to me. All right, a connection must be made between two square vent openings in an air conditioning system. If the sheet metal used to make the connecting piece weighs 0.906 pounds per square foot, what is the total weight of the piece in this figure? So we're talking about sheet metal here, and you can see the weight is described as being per square foot. Of course, the sheet metal has a thickness. It has a third dimension there, but you can get a good idea of you can get the exact weight of it based on just measuring the square feet, because that is a consistent thickness throughout it. So you don't really need that third dimension. You can just say it's the number of pounds per square feet. But when I'm talking about square feet, that means I'm talking about an area. And so if I'm connecting a square hole to another square hole, this one measures 6 inches, this one measures 9 inches on each side, then really what I'm looking for here is the area of these sides. This side here, the one on the bottom, and the one on the far side there. So those 4 sides, in other words, I'm talking about the lateral surface area of this. And it kind of looks like a prism when you first look at it, but the bases are not the same. So this is actually a frustum of a pyramid. So the lateral surface area for the frustum of a pyramid is found through this formula. 1/2, it's the same one we've been using. 1/2 times P1 plus P2 times the slant height. So let me write down what my bases are. So this 6-inch opening is one of the bases. And the perimeter here, I'll call this P1, is 6 times 4, which is 24 inches. I don't need the areas, so I'm not going to bother with them. The other base, this one over here, measures 9 inches, and the perimeter of that base would be 4 times 9, which is 36 inches. All right, so that means the lateral surface area would be 1/2 times 24 plus 36 times the slant height, which says is 28 inches. So 1/2 times parentheses 24 plus 36 times, what was it, 28? We get 840 square inches. That is the lateral surface area, or it's the amount of sheet metal, not counting any overlap, of course, but yeah, we're not counting any overlap here. We're just saying what the lateral surface area is. So that's 840 square inches. We know that this weighs 0.906 pounds per square feet, so the weight, 840 square inches times 0.906 pounds per cubic foot. I'm noticing that I have square inches here and cubic feet, or square feet here. that is a little bit of a problem. I can't just cancel those. So what I'm going to do is I'm going to, kind of in the middle of this problem, I'm going to do my unit conversion, converting inches to feet. Well, inches are on the top part of the fraction, so that means when I'm doing my unit conversion, I want inches to be on the bottom part. So there's 1 foot and 12 inches. And I'll do this a second time since we're dealing with square inches and square feet. So inches will cancel, inches and inches will cancel with the square inches here. Feet and feet will cancel with the square feet here. And you can see we're going to do 840 or times 0.906 and divide by 12 twice. So 840 times 0.906 and divided by 144. 12 squared is 144. So we get 5.285. This is in pounds, looks like. That's the only units that survived my unit conversion there. It doesn't say where to round to, but you can see this is to 3 significant digits. Yeah, I don't know. It doesn't say where to round to. I'm just going to leave it like this.